This is the human impact on ecosystems portion of our unit. As we discussed in class, this is a PowerPoint that was designed for high school students, high school biology class. So some of these slides you aren't going to need, so you're going to see me kind of just fast forward through those. But for the most part, this tackles the human impact portion of our unit very well. So everything that humans use comes from the earth, no matter what it is, whether we eat meat or you eat plants. Um, the cows have to eat the grass, which comes from the earth. The building that you live in is made of materials that is used to that comes from the earth. So everything that we have comes from the earth. So we are completely dependent on it. We can't exist without the earth. However, the earth can exist without us. Earth has a carrying capacity. Remember, carrying capacity is the amount that a specific ecosystem can hold as far as population and being able to sustain them with natural resources and shelter and food, things that they would need. So pretty much Earth can't have an infinite number of people because it doesn't have the resources to sustain that many people. And currently, the Earth has close to 7 billion people living on it, and it's not slowing down. So we have a lot of people on the same planet that we've had since humans have gotten here, and so that means resources are becoming limited. Since technology has advanced, our carrying capacity has also increased because we've had things like gas powered agriculture. So instead of you having to go out early in the morning and getting a plow with one horse and plowing the fields that way, you have a gas powered tractor that helps you pull and harvest everything that you need compared to how it was way back when. Medical advances have increased population growth. A long time ago, women used to die during childbirth, so it was a very difficult process. Um, Many people died of disease that we didn't even have cures for, we didn't even know what they were. Okay, so medical advances have definitely increased population growth because we have less people dying and we have more successful births um, and just overall a healthier lifestyle. Our life expectancy is a lot longer than it was, back in the 19th century. So without technology, how many people could Earth support? You would have to think that you would have to go back to the old age of, only being able to work when the sun was out. I mean, they didn't have streetlights and stuff like that back when we had the Mayans and the Incas and the Aztecs. So you have to think about how, technology has definitely made a huge impact on how we as humans have the ability to do things on Earth. Now, the majority of our energy that we use comes from oil and coal. And oil and coal are made up of dead organisms that over millions and millions of years have formed into concentrated carbon that form into that oil and coal. So fossils and stuff like that have eventually been broken down into oil and coal. And these are what we call non-renewable resources because they're being used faster than they form. Since it takes millions of years to create them, we are using them and we don't have that millions of years to be able to replace what we're using. So that's why it's considered a non-renewable resource. Now, if we had only non-renewable resources and we ran out, what would happen? Well, it would be simple. Like, you wouldn't be able to do the things that we do with it. You would not be able to power a car. You would not have electric in a house. There'd be a lot of different things that we wouldn't be able to do if we had no more oil and coal to use. And that's the thing, is we've become so reliant on it. We have failed as a world population to successfully move on to cleaner and renewable resources. So resources that we use up and that we can replenish or that replenish themselves over time are the renewable resources. So for instance, like wind power, solar power, and the use of water for power. So wind power, as you can see on the bottom there, those are wind turbines which power the city of Fort Lauderdale. Not the whole city, but part of it. They use wind to be able to harvest the energy, harness the energy, and use it to provide electricity. All right, because we live in Florida, we're always going to have wind. It goes back to the previous chapter, the previous unit, when we were talking about land breezes and sea breezes. We're always going to have wind. Solar power is a great investment. FPNL now uses a lot of solar panels in order to power the state of Florida. And the use of water for power is a great one. The Hoover Dam uses water to be able to power the cities around it. And these are all things that are renewable. We can use them and they will replenish. And they're much cleaner forms of energy. Now, the water we drink is considered renewable, but pollution and overuse do threaten the supply. Groundwater in aquifers is being removed faster than it can be replaced. Okay, and as populations get larger, the management of Earth's resources are going to become very important, especially wasteland and how we use our resources, and how we how much of them we use, because we have to consider it's not just us anymore. You know, you're providing for a future generation, and hopefully that future generation will have the ability to use the resources that we've had. Now, not to get confused with a carbon footprint, but an ecological footprint is the amount of land needed to produce and maintain enough food, water, shelter, energy, and waste. Okay, so for you to have a large ecological footprint, you need to have a large amount of land that can sustain you with enough food for everybody that's there. You need to have water, but clean water, not polluted water. You need to be able to have shelter, energy, and an area to collect waste. So having all of those things is your ecological footprint. How much of it you have is the size of your ecological footprint. Where the reverse, your carbon footprint is the more dangerous one. The more carbon you produce, the more carbon emissions you produce, you're making the whole situation worse. So having a high carbon footprint is not the goal that you want to have as a country. Now, each country has a different size ecological footprint, and it makes sense because each country is different in size, different in population and resources. Well, eventually, though, waste management will become important as well, and that's why we have Wally down there. And it makes you kind of think as to maybe this is a reason why, as to why everybody wants to leave and go to Mars so badly. You know, there's a huge race to Mars and getting people to start colonizing on Mars. Well, why? Why would we want to colonize on Mars if everything's okay here on Earth? So, you know, kind of think about how, you know, the same situation with the movie Wall-E, when they kind of, you know, evacuated everybody off the planet because waste got so bad that you couldn't live here anymore. Those are things we have to think of, especially in your generation where you have the opportunity to grow up and change these things. The next thing we're going to move on to is air quality. So each year, humans add synthetic chemicals and materials to the earth, and that's what we call pollution. So pollution can be in the air, the water, or the soil. It doesn't have to be just in the air. Most common air pollution does come from the burning of fossil fuels. Again, fossil fuels is what's coming out, is the gasoline, is what's coming out of your car. So that very nice car that you want, it may be really, really nice, but it may be putting way more of the fossil fuels into the air, causing more of an air pollution problem than we already have. Smog is a type of air pollution caused by the interaction of sunlight with those pollutants that we produce using our vehicles. LA has a very big problem with smog, and that's why over in that area of the country, most kids have problems with asthma and chronic bronchitis and things like that, because the air there is not clean. It's polluted compared to here, how it is in Florida. One of your vocab words was acid precipitation. Acid rain is very similar, okay, if not, it's pretty much the exact same thing. So acid rain is a type of precipitation that's produced when pollutants in the water cycle cause rain pH to drop below normal levels. Well, what's normal level? pH normally for rain is a 5.6, pH of 5.6, and neutral is a 7. So rain is already naturally more acidic, but if it drops below that, that's when we get the acid rain, and that can actually have an effect on lakes and streams, causing a decline in growth rates. And then it can also break down leaves and bark on trees, which means they're vulnerable to weather and disease. And believe it or not, plants and trees do get diseases, and they spread very fast. They spread through the root system. And it's also been known, acid rain has also been known to destroy parts of statues and memorials and things like that as well. The big thing that we have to know here is the greenhouse effect. All right, we're supposed to have greenhouse gases, and in this slide you can see on the left hand side, you're supposed to have this natural greenhouse effect, and that's what's helping to keep the earth nice and warm. Okay, so that way we're not a complete ice ball. That's what we want it to be. That's a natural way. But what has happened because of technology and all the things that we have and the carbon emissions globally, not just in the United States, but everywhere, we have what's on the right hand side. And so you see there that if you compare the two, the amount of solar radiation that's coming in is the same. The amount of radiation that's being reflected off the surface of the earth is the same. What's different is that the amount of radiation that escapes into space is very, very different. And the natural greenhouse effect, the greenhouse gases are much smaller, it's a thinner layer, so there's more heat that's able to escape than when you look at the right, where those greenhouse gases are extremely thick and it's keeping most of the heat in. And this is what's causing most of our big superstorms now that we have in recent times, and that's what's also making it hotter every year. When you get to summer break, it's always hotter and hotter and hotter. That's part of the problem, is this heat can't escape because we keep emitting these greenhouse gases, and it's just getting thicker and thicker along the way. The next section is water quality. So you can put pollutants into the water. When you do that, though, there's an overgrowth of algae and plants, and that lowers the dissolved oxygen, which causes fish to die. Causing that, that's a food source that we no longer have. And once you do that, you also uh, kind of destroy the ecosystem in that area. So that's something that you have to take into account. One way that we know if an ecosystem is healthy is by looking at an indicator species. So, for instance, frogs are a good indicator species. Dolphins, manatees, things like that. If there's something wrong with them, it makes us have to go back and look at everything that could be possibly going wrong in the ecosystem to see if it's an environmental condition or if it's something natural that's going on between them. But if it's an environmental condition, it's something that we have to take care of because we're the ones who are polluting the water. If humans weren't here, the water would have no pollution in it. So those are things we have to take into account and things we have to look for. These are our responsibilities as human beings and citizens of a global citizen, as you would say. We are the biggest threat to biodiversity. We have a major impact. We are threatening animal and plant populations by creating new developments and habitats. The city of Weston was built on the Everglades. We have many medical and technological advancements that come from nature, but sometimes we're using them faster than we can go ahead and replace them, or we're not doing it responsibly. And the loss of biodiversity can make an ecosystem unstable. And as we learned, all the ecosystems are interrelated. So when you mess up one, you mess up the whole thing. So it's a chain reaction. And we have to remember that once something is extinct, it's gone forever. We can't get that back. So the best way to protect anything, whether it's the ecosystem or species, is by conservation. Development has caused habitat loss. As you can see on the bottom, I'm not a rug, I'm not a trinket. Those are posters because these animals are being hunted for sport, for their fur or for their ivory. OSearch up at the top is there's actually an app for it. You could track all of the different sharks that they've tagged, and they're doing research to see how they're migrating and things like that, so we can help preserve their habitats as well. Things like introduced species are threats to biodiversity. So pythons being released into the Everglades, those are harmful. Same thing with plants. There's certain vines that take over and actually are dangerous to the native plants. So the whole thing with conservation is just being more developing sustainable ways of doing it. So not just clear cutting, but selective cutting. Not overfishing, but sort of just going ahead and selecting certain fish or rotating them. We have the Endangered Species Act that came into place to help prevent any um, animals that were endangered from going extinct, and manatees have recently been taken off of the endangered species list. So if you were to put a total value on Earth, it would be $30 trillion, and there's no way that we could afford $30 trillion.